This is section 10.2b, Algebra, Graphing Quadratic Inequalities. Very similar to section 10.2a where we are graphing the lines. Today we're going to be graphing, determining whether something is shaded or not, above and below, and whether we have a dotted line or a solid line. In other words, do we include that part of the parabola as the solution or not? So we're going to use these formulas at the top again to determine how our graph is going to look. So let's look at our first example. First thing we're going to do is establish the values of A, B, and C. In this case, A is 1, B is -2, and C is 3. My next step that I'm going to do is I'm going to find the axis of symmetry. To find the axis of symmetry, we're going to use the equation x equals the opposite of b over 2a. So in this case, that's the opposite of -2 over 2 times 1. Well, that value of x is going to be 1. So we're going to put a dotted line at x equals 1. We use that axis of symmetry to find our vertex. And our vertex has the value 1, 0, remembering that the 1 comes from the axis of symmetry. We plug our value 1 in to find the value of y. 1 squared minus 2 times 1 plus 3. So in this case, 1 minus 2 plus 3, so y equals 2. So our y value is 2. So we go 1, 2 on our graph. Now we're going to find the y-intercept. The y-intercept has the values 0, c. So in this case, that's 0, 3. We're going to take that 0, 3 and we're going to reflect it across the axis of symmetry to 2, 3. Our last step that we're going to do is to find a fourth or a fifth point. To do this, I'm going to pick the value x equals 3 because there's nothing in this vertical column along that. So I'm going to pick x equals 3 and we're going to plug it in. 3 squared minus 2 times 3 plus 3. So that's 9 minus 6 plus 3, or 6. And so we have the point, therefore, 3, 6. So we plot that. That's right there. And now we're going to reflect it across 2 units the other way. It's right here. This is all review at this point of section 2a. Now we're going to focus on this inequality. That inequality is less than. That less than or equals means it's a solid line and it's shaded down. So we're going to make a solid line, which means that's part of our boundary, and we're going to shade everything below the parabola as part of our solution. So any number in the shaded section, if you plugged it back in, would be a true statement for our answer. This finishes up example 1.